Dear friends, dear colleagues, welcome to this second webinar from Dr. Degidi. In this series of two webinars, I am presenting to you my approach in the treatment of the fully dentalus patient or the patient with terminal dentition. In the first webinar, you have seen the technique of intraoral welding to make an immediate screw retain restoration, either in the maxilla or in the mandible. Today, we will see a similar approach, but this time using a conometric abutment. So what is the conometric concept? The conometric concept is potentially a beginning of a new era. You know that until now, there have been many two different ways to make implant support restoration, cemented or screw retained. With the conometric concept, we are going to make a fixed prosthesis on implant retained just by friction. So restoration that cannot be removed by the patient, only by the dentist, without any cement and without any screw hole. And this is achieved just using very simple component that I have designed some years ago. If you look in this picture here, you can see that if you make a slide through the conometric cap and the underlying abutment, you can barely see the contour of the abutment. So the restoration is so precise that there is virtually no gap. So these are the most precise restoration you can ever dream about. Why you need econometric retain restoration? Well, we all know the pros and the cons of cemented and screw retain restoration. Cemented restoration, it has occurred to many of us, I think, to leave some undetected cement without realizing this. And when you realize, sometimes it's too late and you have developed problems. So this is the issue with cemented restoration. And how about screw retain? Well, also screw retain restoration has some limitation. Losing of the screw is just one of these. But most important for me is the fact that the occlusal table is riddled with holes. And you know that a hole is not just about aesthetics. That definitely is not nice. But it's also about weakening the strength of the ceramic in the occlusal table, and also creating occasionally occlusal problem. So no one can really like a restoration that looks like a Swiss cheese. So conometric have the advantage of both this approach, but not the disadvantage. Has the advantage of a cemented restoration, that is an immaculate occlusal table, but doesn't have the disadvantage to have the cement. Has the advantage of a screw retain restoration, that is retrievability, but doesn't have the disadvantage that is a hole in the occlusal table. When I have developed this concept long ago, because this I developed in 2006, so it's now 15 years, I understood that I need to closely balance these three parameters: conical angle, friction coefficient of the metal selected, and insertion force. By calibrating these three parameters, at a certain point, we have been able to reach a retention that is not too little or too much. What do I mean with that? It's not too much that cannot be removed when this may become necessary in the years. And it's not too little that can get disconnected without any advice. So, let's see what are the fundamental prerequisites of econometric restoration. The first is that the cap has to be completely seated. If the cap is not seated completely, you don't have just some retention. You have no retention at all. So you will need to eventually remove every obstacle to the complete fitting of the component. The second point is that it's not enough that the components are fully seated. To be completely retentive, you need to add an impulse applied with some predetermined force. And this impulse will actually create the final sitting. And the third is, of course, that when you are placing many implants, the implants may not be parallel, but the abutment at the end have to be somehow parallel. Why say somehow? Because of course you have some tolerance. You don't need to have the component completely parallel. You may have some tolerance, but of course the tolerance is dictated by the taper of the component. We have 5.7 degrees, so 5.7 multiplied by 2 makes more or less 11 degrees. That is the tolerance that you can have. Okay, so once the abutments are placed in the more or less parallel position, then you have to tie the screw and you're done. I have published several articles on the econometric concept, and these articles you can find in the internet on PubMed. They are published on the most important journal in our field. So, along the years, I have produced documentation, and this is a concept that is pretty much evidence-based today. So let's see now some clinical case. And we will concentrate today more on full arches. Of course, with Conometric, you can make any kind of bridge, but the topic of today is more the fully edentulous. So let's see now a demonstration. Let me open this video. And see, in this video, four implant has been placed. And as you can see, like when we do a screw retain restoration, the two implants in the front have to be placed more or less parallel. The two implants in the distal part have to be placed slightly tilted. This time, we cannot leave the inclined implant tilted without correcting the axis, because this time we want to make a conometric restoration. This means that you have to correct the axis of the implant using an angular abutment. So let's grab some components. These are conometric abutment. The name in this particular case is Syncon 5 degree, straight abutment, and the taper is 5 degree. We put the parallelizing gauges on the top of this, so you have an idea of the axis that you now have to copy. Posteriorly, we have, I've just placed 2 angular abutments to correct the angulation of the implant. So it may be 15, 20, 30, depending on the axis of the implant. Because I'm using an implant that has no index, so the abutment is free to rotate. The abutment has no index, and so can rotate into the implant. So let's see now, I put the parallelizing gauges. Now I rotate the abutment. There we are, until I find some parallelism. So you have seen in this video, it is extremely simple. So now, through the vent of the gauge, you will give some torque to the abutment screw so that the abutment doesn't move anymore. You check once again the parallelism, and if the parallelism is okay, you will further tighten the screw. Okay, so this is all that you have to do. Now apply the final torque according to the one abutment, one time concept. And at this point, the abutment will become one piece with the implant. Literally, there is literally no gap. Now let's apply the conometric abutment. These are conometric caps developed for the Syncon abutment. We normally use this when there is a fully dentulism with a lot of vertical dimension, because these are bulky abutment. So you see now we apply some force on each of these caps, and in this way the caps now are very strongly engaged with the abutment. Okay. It's now time to bend the wire and make the framework. Now see how easy it is to bend and to make the framework on conometrics. Even easier than with screw retain. You see, you just make one bend in correspondence of the first abutment. In the midline, now you make a second bend, and this is your arch that you have somehow shaped. Remember what is the goal of the bending the wire is to achieve passive contact between every abutment. Because now you not have contact on the 2 posterior abutment, you are using the wide angle plier to open the angle of the arch until the metal is touching every abutment and is somehow freestanding. So this is as much time as you need to make to bend the wire, and you are now almost ready to make a framework. And how do we do the framework? Well, in my office we like to do the framework with intraoral welding, like you see exactly now. So you see you have applied the first impulse here, and now you will move to the next contiguous implant and weld on the second spot. And then you move to the third one, and you also make another spot. And let's come now to the last one. Remember what I explained you last time. Let me slow down the video and so you understand the two impulses. The first impulse you have seen now is just warming the metal. And then comes the second impulse, that is the one that makes the actual welding. I think you should have seen very clearly in this video that I intentionally slow down. Okay, so this is the framework done. Compared to any other technique that takes, put impression copying, and impression and model and casting, this is uncomparable because in a minute you have done a framework, a very strong framework. I think this is a big advantage. Okay, now this is your framework. You can tap it out and eventually, if you want, you can put it back in position. And if you tap this with some force, this will be very strongly fixed to the underlying abutment, and you will not detach with your finger. You can lift the table, but you don't remove the framework. So this is a very effective way to make a long-lasting framework retained just by friction without any cement, any screw. So let's see some clinical case. This is a lady that she came for problem in the upper jaw. And so now we will remove all the teeth and make a temporary. Because the idea is to make a second bridge later. So you see she is very neglectful. This is the smile line. And once I have removed the teeth, you see I don't open any flap. And this is an important point that I want to address. That I am not very keen to open flap when this is not necessary, to grind bone, just because your technique requires a lot of inter-arch space. With the Conometric concept and the ankylose implant that can go so deep into the bone, and with the abutment that are just 4 millimeters in height, you occupy very little space. So very often, if you want, you can make what I normally call a socket fit restoration, or the American call an FP1 or FP2 restoration. So what is a socket fit or an FP1? Is a restoration where the dimension of the teeth are more or less similar to the originally dimension of the teeth before they were lost or extracted. The dimension can be more or less the same or slightly longer in case of an FP2 restoration. If you make a restoration like this, you have the advantage, of course, to have a nice aesthetics and much easier cleaning and a better acceptance from the patient, because not many patients like to have a denture screw in their mouth, how sometimes they call it. The limitation of this approach is that the implant have to be placed exactly in the position of the future emerging tooth. Okay, so you cannot put an implant in between two teeth, otherwise your socket fit restoration will look very ugly. So I asked the technician to prepare a white shell, and then I try the shell. And when I try the shell, I see if there is anything that doesn't go correctly in the direction that I want to do, if I have some profile or scallop of the gingiva that I want to change. I ask the patient to bite and to close in occlusion. In this way, I can check the midline, and I can check eventually the vertical and so on. Because I'm not going to open flap, I have a lot of anatomic reference that are not changed, so it is much easier to make a socket fit restoration. Here are the implant plates. Where do they place the implant? Where I place where I have some bone, and hopefully also where the tooth were more or less emerging in the correct position. And you can, of course, put the implant through some computer guide, surgical guide, or you can put them freehand. The socket fit shell is helping you a lot in finding the correct position. So once you place the implant, 4, 5, or 6, normally not more than 6 and not less than 4, in my opinion, then you see what also you additionally have to do. You have to prepare the pontic side. And then you put the abutment, conometric abutment. In the previous case, you have seen the Syncon, that is a conometric abutment line for ankylos. That is mostly used for cases where you have more vertical loss, so where you don't make a socket fit restoration, but on the contrary, you make a hybrid restoration, or the American course, an FP3. Here, because the dimension of the teeth are small, I'm going to use the standard abutment, and the standard abutment are smaller, so in the anterior zone, they are much nicer to develop a nice emergence profile, right? So, in the front, you've seen I put 2 angled standard abutments, standard A. The diameter of the standard A abutment is is 3 millimeters, so it is really a little small abutment. And posterior, where I have more dimension, I put a standard B that is a little bit wider, 4.5 millimeter. Then I put my conometric cap, and then I tap the cap until I feel the cap are engaged. And then I pull the cap to tentatively remove them, because the cap doesn't have to come out. Once you have tapped this, the cap stays in position. If you pull and they come out, something is wrong. That means the cap is not fully seated. And most likely there is a little bit of bone or a little bit of tissue. So you just have to be careful and follow this step. After then, you bend your wire and you make your framework, the way I have just shown you in the video. So this is the framework after we removed. Then you see you can add some retention extraorally. If you want, you can put the framework, sometimes we put the framework in the anodizer machine, just change the color so it looks nicer. And the framework has to be passively housed into the hollow shell. Remember from the last lesson the shell dimensions are 10 millimeter or 8 millimeters here, and so you have to reduce the metal until the framework is very passively fitting into the shell. And this is not difficult with Conometric because the abutments are very small. So once you have achieved this and you have tried this in the mouth as well, you can now reline it. So you will tap again the framework, and then you're going to reline. At this point, when everything is set, you remove and finish. And sometimes there is a little bit of work to create a good pontics. And you all know that the more time you spend to make a good pontics, the better will be the final result. So see the magic of Conometric. No screw hole, but no cement. So how do we fix this? Just with tapping axially on each abutment. Here I'm tapping with a wood stick and a mallet. How much should I tap? How strong should I hit? Well, you just tap until you hear the sound that is becoming from dull will become clear, tympanic. And at this point, the bridge is in position. Grab the bridge with your hand, try to pull it, it won't come out. Great. This is your final result. And this is how the patient can leave the office. You see, this is more or less the copy of the previous bridge, the previous failing bridge. Now this is the copy. Well, this was a temporary, in my opinion. I say the patient, well, keep this for some months and then come to make another one. And you know what? The patient has no money and they say, well, I'm happy with the temporary. And so she's keeping the temporary. Now this is a 1-year control. And this is a 4-year control that we did a couple of months ago. It is still in good condition. And, when she wants, she can always make a new bridge, as these bridges are really pretty much long-lasting. So let's see now another case like this one. Here we have a patient that in the maxilla has a denture, and in the mandible has some failing teeth. So what we have just seen is going to be a socket fit restoration in the mandible, but in the maxilla it's too late for the socket fit, so this will be a hybrid restoration with pink acrylic. So plan is for implant, and of course to minimize the cantilever length, the 2 distal implant has to be tilted a little bit, so I needed to correct the axis, once again using the Conometric abutment from the Syncon system. So these are the parallelized abutment, and this is the framework done, once again, with the same technique. It is just, this time we make it pink because it has to go in a pink restoration. And we use this is a strong abutment that we use for cantilever. Now the shell that can also be the existing denture or a specific design prepare shell will be filled with some pink composite, and you will grab the framework, and once it's set, remove it until this is finished in your hand. So, okay, so this is your 12-arch bridge, retained just by friction, made with commercial denture teeth, and tap once again in position. Okay, so tap, tap, and tap, and finish the bridge. So this is how we make a hybrid Conometric restoration. some years later, this patient kept these teeth for long. Then years later, when the teeth in the mandible were failing, we decided to replace them and to put just 4 implants. Canine molar, I guess. Small abutment is easier in the mandible to put the implant parallel. In this way, you can just use the straight abutment, so you don't have to parallelize anything. So it's not a bad idea to spend a little deal of your time trying to put the implant parallel. This is why computer-guided surgery is a great synergy with Conometric, because through the computer planning you can put the implant as often as possible parallel. It's more easy. Nevertheless, I do this freehand. I put 4 implant, 4 cap, and then once again create an immediate framework using the intraoral welding technique, as I have taught you last lesson. Okay. So this is your framework. I don't know, friends, if you at this point you have become believers, because either you become believers or you don't like this technique. But if you become believer, I tell you, this framework here is something terrific. You make a framework with a wire that costs you €5, and you bend it very easily. And this framework is not one of those Mickey Mouse framework. This is serious stuff. This framework will not break, not before 10 or 15 years, okay? Not for sure. So it is very strong. So you can rely a lot on this. And it's quite easy and passive. So this is our socket fit bridge. As I say, to make a socket fit bridge, the only problem is that implant has to be placed under the corresponding tooth. But of course, this is not so difficult. Just need a little bit of your time. So let's now put the bridge in position and then engage by, once again, tapping on the bridge. Okay? So, socket fit in the mandible, hybrid in the maxilla. You have seen a case like this. I think it's an interesting case. This is the panoramic. And then we let the patient go. Now, this is now I think that any patient with this kind of prosthesis could stay forever, because this restoration will not break. They will not chip. Or if you have a little chipping, it's so easy to fix. You can replace, of course, with more expensive restoration. This is up to you and up to the patient budget. But eventually you can leave this for long. This patient has no economical problem, and so he agreed to replace this with another restoration. But honestly, this was not really 100% necessary. So when the time comes that you decide to replace this restoration with new one, the first thing you do, you disconnect the bridge, and you see how marvelous are the tissue underneath this. Then I tell you, we don't take impression on the copings. We just take 2 alginate of the temporaries. You see, we take 2 alginate of the temporary, because the temporaries have been in the mouth for years, and they have all the information that the lab technician needs to have. So the temporary are now, you see, embedded into the alginate, and then the lab technician will put the implant analog and the fake gingiva, all the things to make the model. And once he has made the model and the mask and the stone as set, then it will return to you the temporary, and you will put the temporary back in the patient's mouth. So patient wait 2-3 hours in the office, but at this point we are absolutely sure that everything is correct. So we don't make a try. We just ask for the final restoration, and the next step we deliver the final bridge in both arches. This is what we normally do in cases like this. See how the tissue are nice underneath, and you don't think that this patient has been flossing and brushing a lot. This is always the cases of such a nice tissue. And this is because of conometric gap-free restoration. And okay, so finally you got the final bridge. This is a zirconia framework with some lithium disilicate single crown. And what this cap are still the same welding cap. Are the cap where we just cut the stem, make some undercut, as you can see, and then cement. We cement the bridge, this bridge, on the top of this cap. We wait for setting of the cement, then we tap out the bridge. We wipe out the cement that can be excessive. This is very easy to take out. And this point, we put the bridge back in position, and again we activate this with tapping, and the same we do with the lower. Now in the upper is an hybrid restoration, in the lower is a monolithic socket fit with once again with zirconia, and then you finish. Put the cap here. Now we opaque the cap because it's whitish. And then we cement the bridge on the top of the cap, and that is the end of the lower arch. And these are the two arches together, okay? So this is an interesting case because it represents every possibility. You have seen two different kinds of temporaries and two different kinds of final bridge, but the concept is the same. This is at the end of the prosthesis delivery, and this is a 5-year picture during the session of hygiene, and the next ray 5 years later. Well, not every patient can afford to pay such a nice but expensive restoration. So I want to show now you 4 cases where I have used a different approach to make what I call a durable restoration. Durable restoration means a restoration delivered just in one appointment with material that are supposed to last for at least 10 years. So the first approach is the more traditional, the more analog approach. We use commercial denture teeth, top quality of this major brand, as you can see here. So if a patient comes like this one, with a denture in the opposing arch and a mobile prosthesis in the lower, requiring a fixed one, we can deliver immediately a final bridge. So this time open the flap, do some osteoplasty, place the implant, then put the silicone abutment, parallelize the abutment, and once they are parallel, put the cap and create the framework. And then use this framework to modify, opaque it, and finally reline your shell or the existing denture on the top of the framework. At this point, finish this. And this is your fixed bridge. It's made with denture teeth, as a strong framework done with the intraoral welding technique, and a terrific precision because is conometric. So it's a very interesting kind of prosthesis, my friend. And yes, I call this a final restoration. Well, in the upper jaw, this gentleman has a denture. So for what reason should we make a monolithic zirconia restoration in the lower, a very expensive restoration? This is a very inexpensive restoration. But the patient loves this because it's fixed. And because when you want to remove it, you will remove it in 1 second, just tapping out. And when you have a chipping, if you ever have a chipping, you can fix and repair this with little time and extremely limited cost. So it is a good restoration. And this has been done in 2009, and this is a follow-up 9 years later, and everything is fine. And then the patient died, and so we have no longer follow-up. Sometimes this kind of restoration in patient that has an opposing arch that are a little bit more aggressive compared to a denture, you can have that the commercial denture teeth can get worn off after some years. So that's why we have developed this concept here that you can see in this case. Here we are going to treat the maxilla. And I have prepared a template to do the scan because in this case I want to make a guide surgery. So I plan to place 6 implants here. And this is my guide. I'm going to use, in this particular case, a hybrid ceramic to prepare just the posterior part of the shell. So instead of commercial denture teeth that are strong but have just a little millimeter of composite in the top, and they can worn off more quickly, in this case, I will use a hybrid ceramic. What is hybrid ceramic? Well, this is a block of kind of composite that are made by metal methacrylate and anorganic silica. And it basically is, you see, more or less half methyl methacrylate, half silica, depending if you measure the volume or the weight. What is important to know from this material is that the wear resistance of this hybrid ceramic block is absolutely terrific. So we have developed this technique where we are using the blocks to make the posterior bridge. And then we hollow this bridge, and we include it in our shell. So now we have a shell that posteriorly has, you see, 6 teeth made with hybrid ceramic. So these teeth are very resistant to abrasion. In the front, we are still using commercial denture teeth. Why? Because they are much more nicer. The aesthetic is beautiful. It's more beautiful. Hybrid ceramic are monolayer, just one layer, and sometimes the aesthetic in some patients cannot be accepted. So you see again the shell here, the posterior hybrid ceramic shell, and anterior. Now, day of the surgery, we take the teeth out, we put the shell in position, we do our check, midline, vertical, then we prepare the hole and place the implant in the position that we had selected. Then we parallelize the abutment. 4 abutments are parallel, as you can see here. So we use 4 implant parallel, so we just straight abutment, and 2 are a little bit tilted. And see how these abutments are small. Because the abutments are so small, it's much easier for you to develop an emergence profile that maintain the originally small dimension of the teeth. Now, see the abutment has been parallelized. I have done a little augmentation because one tooth would have been a little bit too long for my aesthetic. And at the end, everything is now ready for welding. I have weld and create my framework. And this is once again my shell and my final restoration. This is the Conometric restoration, socket fit, hybrid posteriorly, and let's say commercial teeth anteriorly. See, it again fixated exactly in the same way, and that is the final result. I think it's quite acceptable. This posterior teeth will never be worn off, and I've been using this material now is the 7 years, so not so many, but I can tell you they behave extremely well. And if the patient comes one day for an hygiene session, you see, these are the teeth. You take them out in 1 second with the spring remover and see the membrane tissue. Then you just clean it outside the mouth and put it back. And that is one of the many advantages of the Conometric concept. Another possibility is to make a shell completely done with hybrid ceramic. We do this when aesthetic is not a big request. But of course, to have a shell that is completely a monolithic shell, well, make your final restoration really very strong. So we are going to treat the mandible of this patient. So the lab technician will make the copy of the denture, the silicone mask, and then he will put some cap in the stone. So otherwise the scanner will be confused. And then he start, do the planning, the digital planning of this particular patient here. And once everything is as a plan and he like this, then he will grab a disc of this hybrid ceramic and mill it. He will mill the bridge from that. Okay. Then after the milling, he will polish and just leave some empty space for the future abutment. See, these are the position. And because he has already a denture and has lost a lot of vertical space, we decide to make an hybrid bridge. So this is why he also add now the pink part still on the model on the hybrid ceramic. Okay, and that is how they make this lab step. Ready. Now, once this material is eventually set, you have this bridge that is made of acrylic, pressed acrylic here, and hybrid ceramic all the way around. So this is a full hybrid ceramic bridge ready for the surgery. So it's now hollowed. We leave the trigon to get some reference during the surgery. Now, let's open the flap here, because you see there is very little attached tissue. see where the nerves are, and this is not a good surprise because you see this is a very poor arch shape. Is the worst that can happen to you, is the square mandible. So that means that all the implant will be more or less in one line, and your cantilever will be very long. And cantilever is always your enemy when you make an immediate breach, but in general, also with the most expensive material. Remember, fatigue will always present the bill. So do not exceed in cantilever. If you can, don't make the cantilever. But sometimes you cannot make a too short arch, so you have to cantilever. So here the mandible being prepared, I put the implant, I spread the implant as much as I can, parallelize the abutment, and finally use this abutment design also by me. That is an abutment that I use when I have to make a long cantilever. This is very strong and is pre-welded in the factory, so it is really one piece abutment. So now I have made my framework once again in one step. Because, my friend, what we have to understand is that if we can make a final restoration in just one appointment, then you will make also some money, because time is our most precious resource. So this is your hybrid shell. It has to fit the framework. Now put the framework back, reline with some pink composite, and that is your bridge. Finish. There you go. The denture, the copy, and the final restoration that finally you can tap in position with this new device that I've developed, that is delivering every time the same amount of force that is necessary to permanently fix the conometric bridge. Okay, so 1, 2, 3, 4, 1, 2, 3, 4, and this is now fixed. Okay, once again, is the final bridge. Now this is hybrid, aesthetic is what it is, but for this patient is more than acceptable. He liked this very much. That is some control some years later. Now let's see another case. Here we have a patient that is a dentulous, has true denture, but he has a problem. He has a pacemaker. So I cannot use my beloved approach, that is intraoral welding, because welding creates a huge magnetic field, and so it's somehow contraindicated when the patient has a pacemaker. So we have to find another way to make a framework. So first of all, again, guide surgery. Why guide surgery? Because he's an old man. I want to make both arches in just one session, but I don't want to keep him in the office for too many hours. So guide surgery has the advantage that the surgery is quicker. And the second advantage is that I can really plan, and if I have the bone, to put the implant parallel. So then I can just use straight abutment. So everything becomes extremely fast and easy. So here is the plan in the mandible and in the maxilla. 8 implant, very, very all parallel and fast. So we receive the surgical guide, and once we get the guide, the lab technician will make the model, same way. And once he has the model, we have to plan what to do. So we put the abutment, the same abutment that we plan on the digital planning. So standard abutment, straight abutment. We put on the abutment the cap. These are the welding cap where we have just cut the stem. And once we put them, he will have now prepared this kind of for show made, for example, in this case of fiberglass. As I tell you, we cannot weld in the mouth, and you cannot weld on the model because you will not be passive when you go in the mouth. So you will need some other material to splint the abutment. And one of the potential material is fiberglass. Yes, we can use other material, zirconia, whatever, but they are expensive and they are don't forgive you. But this is very easy. You can trim this, you can cut this, and you can adjust. On the other side, they are extremely strong. Flexural strength of this material, fiberglass, is more than 500 megapascal. So they are quite strong. So lab technician designed with a pencil how he would want to have the framework, and then he will just cut this very quickly and fit on the models. And this is what he is going to give to me the day of the surgery. So I will have the template and the fiberglass frame, and of course the Conometric cap. So let's go in the mouth. Let's put the implant with the guide surgery, take the carrier out, put the straight abutment, the very same abutment that you have used for planning and that lab technician has used on the model. And then at this point, put the Conometric cap, take the existing denture, hollow the denture, make the space for the framework. Try this, of course. Then put the fiberglass framework. We put a little bit of permanent cement here in the hollow space of the framework. Cement intraorally on the cap. Do not remove this because now you are going to cement also to reline the denture on the fiberglass. So now we have all this sandwich of stuff. Leave this in occlusion. These are the existing denture, so no issue. Remove everything, and then, once again, the lab technician has to fix everything, to prep, to finish, to put some color, and then it will deliver this. Once again, it's a strong restoration. The internal part is fiberglass, external part are denture teeth. You can now fix the same way, tapping actually on the abutment, and that is your bridge, ready to be to go home with the patient. Okay, and this is another way that you can use to make econometric full arch restoration if you are not a welder. A last case is this one. Sometimes the patient comes with a lot of bone in the maxilla. I think this is happened in my life once in the last 40 years, so not very often. Patient comes and say, you know, doctor, I have done 20 dentures, 20 dentists, no one can make me happy. And the reason was, of course, that she doesn't need a hybrid restoration. She needs a socket fit restoration because she doesn't have all this space and she has too much bone. So once again, I scan this case. I see the implants are lost in so much bone. It's not easy to find so much bone. And I make, once again, same step, the model. And once everything is prepared, I put the abutment, the cap. And at this point, we have to decide what material to use. And we thought, well, this is a very easy case with a lot of bone, so let's make it already a finer bridge in zirconia. So here is the zirconia that the lab technician made on this model. And he finished directly the bridge, veneering and layering with ceramic, and ready for the day of the surgery. So the day of the surgery, surgical guide, 4 implants. And now what? Now you have to prepare all the pontics. And it requires more time than to do the surgery, because you really have to carve and to make all the pontics for the future teeth. Once everything is being done, then you have now your zirconia bridge. And see, put the conometric cap intraorally on the abutment, tap the cap so that the cap are engaged. You have to be sure that the cap are fully seated. See that everything is fine. And now put some cement. Put some cement in the zirconia bridge. You have done some undercut in the zirconia, some undercut in the abutment. This is more than enough to guarantee a good attachment. And once everything is set, you remove your bridge, and you just have to wipe the cement out, return the bridge into the mouth, put the bridge in position, and again, and tap actually on each abutment. And that is, of course, another possibility. This is a control 2 weeks later, and this is a control 5 years. Sorry, this is a control 2 weeks. This is a control 5 years later, and you see everything is just great. Soft tissue love this kind of approach. It's just that it's not so common to have so much bone, of course. And this is an X-ray 5 years control. So you have seen some of the possibilities, but you can imagine there are countless of possibilities, because every material goes together Conometrics. I show you more of my favorite approach because I think intraoral welding is so easy, so quick, so passive, so strong, and so inexpensive that nobody can really beat this. How about hygiene? I understand that there are dentists that when the patient comes with an all-on-4 to the hygiene session, they remove it. This means they have to remove 4 screws, because everywhere in the world the all-on-4 means screw retain restoration. Now, let me tell you that this is a lot of work. To remove a screw retain restoration is a lot of work, and in my opinion is a lot of useless work. But if the restoration is Conometric, then it's magic. Let's see. On the left side, we have a patient that has 2 Conometric full arch bridge. On the right side, 2 screw retain full arch restoration. And the dentist, that is me in this case, on the left side, with a simple crown and bridge spring remover, takes the restoration out in a matter of seconds. While on the other side, on the screw retain bridge, you need a lot of time, because you have to open the holes, and then you have to take the pellet out and the screw and so on. So in my hand is 18 minutes versus half a minute. Then clean the restoration, because this is the reason why you take them out. And finally, ready to go back. And once again, no one can beat Conometric. You put your bridge in position, and well, now you have this, but normally you take this instrument and tap, 4 taps, and the restoration is completely fixed. The poor dentist on the right side has to do a lot of work. You know how it is. Put the bridge back, put the screw back. Sometimes you even have to change the screw. Then put the pellet, then put the composite, then cure it. And then do the same in the posing arms. And then ask the patient, Is everything okay? Oh, you know what? It's a little bit high here, it's a little bit high there. We know how it is. And so it takes time. You see 38 minutes plus 18 is an hour, is a wasted hour. How much you want to charge this patient for hygiene? But here is 1 minute. So I think this is really a big advantage. Now with Conometric you can also make bridge and single, but these are really two additional webinars if you want to have them, because there is a lot of possibilities. So I just show you one potential bridge, like 2 implants, 2 abutment, 2 cap, a framework, a modified framework, opaque, reline, and a good temporary, immediate temporary. That is what you do. You have done this in this patient mouth 5 times along the ears. Finally, one day, you make new bridge. See the beautiful tissue, and now a Conometric bridge. Tap the bridge in position. No screw, hole, no cement. This is magic, my friend. This is fantastic. It's a strong bridge, it's beautiful, it's the most precise bridge in the world. And you can repeat this on each side of the patient, left, right, lower, upper, with monolithic material, or here in this case with metal ceramic, whatever going to use, still Conometrics win above the others. So this is just one way to make a Conometric bridge, but there are countless ways. And how about single? Well, singles are a little bit more tricky, because you see all the abutment that I have developed along the ears are designed for multiple restoration. So they have, but for single restoration, you need an Conometric abutment with an index. And so, together with Dentsply, we have developed a dedicated abutment just for singles. The name is Aquaris. And again, you see, it's the same concept. You have a cap that is cemented into the crown, and in the mouth you have an abutment that is matching the triangle. In the cap, Conometric cap, you have a triangle here that has to match the triangle on the abutment. And then you have also other features. You have a cylinder, you have a cone, but this will not be discussed in this lecture here. Let's see just one case. A failing tooth, a young patient, gum is mine. What is the best treatment plan? Immediate placement with ankylose. Put the implant in position, reline the crown, send the patient home. Let the patient heal, and finally, when the time comes, you will take the impression. So, he comes in the office with a temporary that he has worn for many months. Take any instrument, grab the temporary, pull, and remove it. See the soft tissue are marvelous, no major surgery, no connective graft, just immediate implantation and lowly. Now take the impression, analog or digital. This is an analog impression, as you can see. So take the impression and wait for setting, remove the tray, and then take the temporary, click the temporary on, and goodbye. Patient can go home. You have finished. Now, the next appointment, you're ready to deliver the final crown. So, once again, disconnect the temporary. This is the final crown. You have to match the two triangle now. So, gently, you push until you feel that the crown is in position. I'm not tapping, just pushing with the foot stick. And now the crown is in position. If you pull with your finger, it will not come out. Okay, let me go back 1 second. This is important. Okay. So the crown, you push the crown until you feel the crown is seated. Then you grab the crown with the finger. If the crown will not come out, that means the crown is in the final position. You have checked, of course, the contact point, the shade, the measures profile, everything that you normally check with any other approach. At this point, you can grab your sitting instrument. There are 3 different tips, concave, convex, or U-shape. You take the U-shape, that is the best one for a central incisor. Put the U-shape disposable pick keep, and then just deliver one blow. Let the instrument shot. And one shot is enough to permanently engage your crown that at this point will never come loose unless you have to take this out with, once again, with a dedicated instrument. Okay? This is the X-ray 1 year, this is 2 years. There are not longer follow-up because this concept has been around released in 2018. So in conclusion, what are the benefits of the Conometric concept? Well, most important, forget the screw hole and forget the cement. That is, I think, is the dream that comes through. Retrievability. Anytime you need to remove the restoration because you want to inspect the implant, you want to probe the implant, you have a problem in the implant, whatever, you can take this out in seconds. And this makes your life much easier as a dentist. You see, time to remove the crown, take this big plier, specifically designed by me, and retrieve the crown. Third very important point is gap-free restoration. This restoration has no gap. When I say no gap, I mean 0 gap. And so this means that your restorations are so precise. You see, let me blow up this area that is the transitional zone between the abutment and the crown, and see, even at this huge magnification, no gap. So any prosthodontic in the world would love to have this kind of precision, and it's very easy. And because you have no gap, that means you have no bacteria. This study made by Peter Gerke and several other colleagues have demonstrated that if they inoculate bacteria into the cap, these bacteria will not come out. And if they put the bacteria outside, they won't come in. So they are not be able to grow any bacteria because the gap is 0. So it's not bad to have a bacteria-free restoration. This also means that the position of the margin of the crown is no longer an issue. You don't have to put the margin of the crown slightly under the soft tissue. You can put the margin where you want. Sometimes it's necessary because you have no vertical space. You can put the margin even into the bone. You will not see resorption whatsoever. A merger profile. Well, today is very common to design the merger profile of your restoration with big abutment, huge abutment, I would say, customized abutment, beautiful abutment, expensive abutment. But with this concept, you make the merger profile with the crown. So what is the difference? Well, the difference is that we have no cement, so we have no defect. And the second difference is that if for any reason you have a problem because the tissue shrink along the ears and you have to recontour the crown, with customized abutment, you can't do that. You have to start and do everything new, a completely new crown. With Conometric, you just take the crown out and reshape a little bit the crown and put it back. And that is another big advantage. Treatment time. Treatment time is really pretty much reduced. You have seen here in the single, but also in multiple, it saves you a lot of hours, I promise. And we are using almost exclusively this approach in my office. And since we have been using this systematically, I mean, you can finish 2 hours earlier every day or treat more patients. It is really as simple as it is, abutment, cap, and crown. It is very versatile. It goes together with any material, lithium disilicate, zirconia, metal ceramic, hybrid ceramic, composite, whatever you like, loves Conometric. Another advantage is the one abutment one time. Because the abutments are so small, you can use the abutment instead of healing screw when you don't want to load. Because they are very, 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 very small. The abutment height is 4.1 millimeter, 4 millimeters. And so this is another advantage. So with this, I have finished this lecture. I encourage you to visit our website if you want to continue education, if you want to make a trip to Italy. If you can fly, I don't know. We have been canceling our course, and the next one now is this in July. It is possible that we will do or not. If you want to eventually to come, you just make frame this QR and and let's go and plan a visit to Italy, or eventually follow us online on some other masterclass. And now I'm waiting for your question. Meanwhile, I give you my blessing from the terrace of my office in Bologna. So let's see. Question. I have here 3 questions. Can we make flanges in the prosthesis of the Conometric concept to get lip support? So if this question means that you are aiming to make a removable restoration, this you can't do. With Conometric, you can only make fixed restoration. So if you want to make a flange, because your patient needs a lot of support, and you think it's better to make an overdenture, Conometric is not your system. Okay. If, on the contrary, this question wants to know if we can make a pink part, I think I have shown in my lecture that you can make you can support the lip with a pink acrylic or composite as much as you want. So this is doable, of course. Is it dangerous for the implant to use the crown remover? Why should it be? No, there is. I mean, if the implant is healed and you want to remove the crown or the bridge, of course there is no risk. You just grab the crown and pull it, or tap the bridge out with the spring remover. If you mean because if you do this when this is an immediate place implant, and you want to tap out, in this case you have to be careful. There is a threshold for Conometric, and while with screw retainer restoration you can load implant with very little torque, as I shown in my previous lecture. With Conometric, you should have at least 25 Newton of final torque. Otherwise, tapping, pulling could not be a good idea. If the implant has just 10 Newton, it might be that implant comes out with the cap. So, can you recommend the brand, the crown remover? Well, they are made by Ustomed. Ustomed is a German company, but eventually, yes, you go on the internet and you can. The name of this instrument is Conogrip. Conogrip. But if you tap dial the Ustomed company, you will find the Conogrip or the Conometric instrument of Dr. Degidi. So I think there are no additional questions. So let me know if you have any further request. You can send an email. I always answer to everybody. And with this one, I say goodbye to all of you. Thank you very much and arrivederci. O do svidania. Thank you. Bye-bye.